Hello, everybody. Welcome in. Today, I'm really excited to talk about one of the most requested features, I think, for Ambient that we've had since we released Ambient, and that is multi-cluster support. I'm Steven. Whoops. I'm a software engineer at Microsoft. I'm a UX, networking, and product security working group maintainer for the Istio.
And I'm Jackie Maertens. I'm a senior software engineer at Microsoft. I'm a security maintainer for Istio and a product security working group co-lead.
So today, first, we'll talk about some of our foundational concepts and generally multi-cluster. Then Jackie's going to talk about the control plane, the data plane. I'm going to review some traffic patterns and examples. And finally, we're going to look at what's next. So multi-cluster is really nice. It allows you to have clusters in multiple regions, increasing your reliability. It allows you to be closer to your customers. Lots of reasons why you'd want to do multi-cluster. But it also presents some pretty new challenges that I don't think Kubernetes was originally designed to deal with. For example, if you have two pods in different pod networks, how do they connect? How do they even know about each other? And when they, or if they do connect, how do you do it securely, especially now that you're going over the public internet? And then you need some sort of entry point into your cluster. And the approach we chose to take, and what many other multi-cluster solutions take, is a base assumption of namespace sameness. And this is a service and service accounts with the same name and namespace are considered to be equivalent across clusters. So here we have cluster A and cluster B. Each has a namespace A, and each has a service A. From the point of view of Kubernetes, these are different services because they exist in different clusters. But what the view Istio is going to take is that this is one service that extends across multiple namespaces. And in this sense, each pod, whether it be in cluster A or cluster B, is a valid endpoint for service A. The story is similar with service accounts. When we apply any kind of auth policy, we don't really look at where each service accounts come from or where their certificates were minted. One thing to note is that even though we don't care about where the service accounts come from, we do allow auth policy to vary across clusters. So even though service accounts with the same name and namespace are considered equivalent across clusters, the actual policies, when enforced, could be different across clusters.
Okay, so while the concept of namespace sameness is the same for both ambient and sidecar multi-cluster, how we scope the view of services are different. So for ambient, we introduced a new API, which everyone loves when we do that, and it's called the service scope config, and it's defined and specified in the mesh config, and it defines the service visibility for proxies via namespace and service selectors. Okay, so by default, all services are considered locally scoped. So proxies are only programmed with the local endpoints or cluster local endpoints for service. Okay, so for example, if you have a client on cluster A that's making a request to a server service, the client's proxy, whether that be ztunnel or waypoint, will only see the cluster A's endpoint for that server service. So it will only make the request to the local endpoint for the server service. It does not have visibility into the server service on cluster B or on cluster C. Okay, so via the service scope config, a cluster admin or anyone with permissions to modify the mesh config can configure label criteria for global scoped services. So in this case, what this means for a proxy is they have visibility into all local and cluster remote endpoints for a service. So in this case, we're specifying an istio.out/global equals true as our label for selecting global services. So in the same scenario we had before, a client on cluster A making a request to the server service will have visibility into all the server service endpoints because it's considered global. Okay, so it might sound like service scope has too much scope and overlap with other existing Istio resources, but it's just about endpoint visibility or service visibility from a proxy. So it's not a security policy, so it doesn't replace the authorization policy, and it's not for load balancing, so it doesn't replace destination rule. And while it does change the endpoints and services that are visible to the proxy, it doesn't change what services are discovered by the control plane. So it does require uniform configuration. So that means the service scope config that you imply in one cluster has to be the same in all of your clusters in your multi-cluster environment. And again, like I said, it does determine the configuration that is sent to the data plane. So it does perform filtering, and then it filters that configuration that's sent to your Z-tunnels, waypoints, and east-west gateways. Okay, so how does Istio go about discovering this remote configuration? Well, the alpha implementation of Ambient Multicluster supports a multi-primary architecture. So that means each cluster has its own Istio-D and API server. And to discover this remote configuration, Istio-D pulls the config from the remote API servers. And then using the service scope configuration that you define in the mesh config, Istio-D will filter that configuration, like I said, and that's collected from those remote API servers, and then share it to its cluster local proxies. So, and again, Istio-D does not discover all policy from these remote API servers. It does not discover all configuration, namely it does not discover remote policy. So it knows about services and others, but it does not discover policy. Okay, so now that we've reviewed how the control plane discovers and filters configuration, we can review what components enable us to achieve the cross-cluster connectivity. So both in ambient and sidecar multi-cluster, the east-west gateway provides an entry point to the cluster without any L3 configuration, and this is via an IP that is routable and discoverable globally. Okay, so this configuration allows multi-cluster support to be somewhat independent of IP topology and defining any networking rules or routing rules. So in this example, the client communicates the intended destination to the east-west gateway, and then the east-west gateway opaquely forwards and load balances the client's request without applying any policy. So in ambient mode, we wanted to do a little bit more. So we wanted to design a design that would enforce identity at the gateway and then avoid any S&I tricks that we do with sidecar multi-cluster, cross-cluster connectivity, and avoid terminating TLS to verify that identity at the gateway. Okay, so introducing the concept of double H-bone. This is how we enable identity verification at the gateway without terminating TLS and hacking S&I. So H-bone you're probably already familiar with if you're familiar with ambient. So it's HTTP connect tunnel with MTLS. So double H-bone encapsulates an inner H-bone tunnel in another outer H-bone tunnel. So in case that wasn't super clear, maybe the goals will make it a little bit more clear. So our goal is to verify the client identity at the east-west gateway, ensuring that it is coming from within the mesh. And also identify the client identity and server identity again at the destination and client Z-tunnel or waypoint. And then to accomplish this, the gateway is terminating the outer H-bone tunnel to verify the identity and determine the original destination port. And this allows the inner H-bone connection to be opaquely forwarded by the gateway to the original destination, be that, and then via a Z-tunnel or waypoint. Okay, so let's walk through an example of how double H-bone accomplishes the goal of identity verification at both the east-west gateway and the Z-tunnel. So we have two clusters. We have cluster A and cluster B. We have a client on cluster A and a server on cluster B. So the client on cluster A sends a traffic request to the server service that is intercepted by Z-tunnel. So far, this is same as ambient, non-multi-cluster. So since the server is labeled to be globally scoped the Z tunnel on cluster A has visibility of this remote server's service endpoint. Okay, so any component that's initiating cross-cluster traffic will communicate with double HBone that we just covered. So in this case, it's going to be Z tunnel because there's no waypoint. So Z tunnel shares the client's identity, not its own, with the east-west gateway for it to verify and then establish this outer HBone tunnel. So once established, the Z tunnel can initiate an inner HBone tunnel with MTLS. So the client and server Z tunnels exchange the client and server certificates, and once verified, the inner HBone connection is established. So while the gateway terminates the outer HBone connection, it is opaquely forwarded. The inner HBone connection is opaquely forwarded to the Z tunnel, and the server Z tunnel terminates that inner HBone and forwards the request to the server. Okay, so when you configure your server to use a waypoint, and so you can note there's a use waypoint label on the server, you have a similar workflow. You'll still have end-to-end encrypted traffic and identity verification at the gateway. In this example, let's say you have a single waypoint on your remote cluster. So in this case, it's cluster B. So the east-west gateway sees the service is configured to use a waypoint and opaquely forwards the inner HBone connection to the waypoint. Waypoint would then terminate that inner HBone request and send a request to the server via a new HBone connection that is intercepted by Z-tunnel. Okay, so now let's consider if we had a waypoint on cluster A, so the local cluster to the client. So instead of Z-tunnel establishing double HBone with the east-west gateway, the waypoint is actually going to be the one establishing this double HBone. And by default, Z-tunnel will prefer the cluster local waypoint unless otherwise specified. So the waypoint, again, is also capable, like Z-tunnel, of establishing this double HBone. And you might be wondering, okay, how does the east-west gateway know that it shouldn't also, because it sees that the server has a use waypoint, how does it know that it shouldn't send the traffic again to a waypoint? The double HBone protocol, we've designed it so that it has a way of signaling that to an east-west gateway or whatever component that the traffic and policy has already been applied. So the goal is that we're not applying policy twice at these waypoints.
To put it all together, I'm going to go over some examples of how you can use ambient multi-cluster to get much more reliable deployments. So as before, we have two clusters, some nodes, a client, a server, and these are all enrolled in Z-tunnel. The usual flow is client traffic gets intercepted, tunneled through HBone, and the destination HBone decrypts the traffic and forwards plain text. If the server pod in cluster A becomes unhealthy, then unfortunately, Z-tunnel has no choice but to fail the request, even though there's a perfectly healthy server pod in cluster B. So if we install an ambient multi-cluster, that's an east-west gateway in both clusters, I'm only showing it for cluster B, and we use a service scope API and label our server services as global, then Z-tunnel, the client Z-tunnel has, as before, the choice to keep traffic local, or as Jackie just mentioned, because it knows about server pods in cluster B, or the existence of server pods in cluster B, it will use double HBone to connect to the east-west gateway, and the east-west gateway will opaquely forward traffic to the destination Z-tunnel, which will decrypt it to the server. That way, if, as before, the server pod in cluster A starts crashing, if it becomes unhealthy, then the Z-tunnel, client Z-tunnel, can keep on forwarding traffic to cluster B, no interruptions. For L7 failures, the story is similar. As before, if we label the server service with a use waypoint label, then traffic can stay local. Or the waypoint has a choice of doing double HBone to cluster B. And again, note that the waypoint in cluster B gets skipped. So now if you remember the 500 internal error we had earlier, before ztunnel would have been happy to forward traffic to that server or the server in cluster B because the ztunnel doesn't know about L7 errors. But now with waypoints, we can configure outlier detection and say if there are too many 500 errors on an endpoint, we can mark it as unhealthy, and then this will send traffic to cluster B. You can actually get really crazy with this. So here we have two east-west gateways, both shown, and then we only have the waypoint in cluster B. So what the ztunnel will do is, seeing that the server service has the waypoint label, is it'll try to hit a waypoint. It'll see that there's nothing local, and it'll have no choice but to fail over to the one in cluster B. But the waypoint in cluster B, because it also is programmed with knowledge of all the endpoints across all clusters because of the service scope config, has a choice to keep traffic local, or it can initiate another double H mode to a remote cluster, say back to cluster A, and then connect to the server pod in cluster A. And maybe this could be a third or a third cluster, say cluster C, and instead of going back to cluster A, it could go to cluster C. And one thing I really want you folks to walk away with from this presentation is that ambient multi-cluster is built on top of the ambient architecture. It's still the case that ztunnel does all the L4. The waypoint does all the L7. The big difference is now that we introduce an east-west gateway that provides cross-cluster connectivity. And the important thing is that it provides this cross-cluster connectivity with identity verification at each step. So you're sure that the only traffic that you're letting into your mesh through that gateway is from your mesh. And it gives you more resilience by allowing you to do cross-cluster connectivity and failover at each step, whether it's from ztunnel to waypoint or waypoint to endpoint. And I think it's important to compare this ambient multi-cluster to sidecar multi-cluster. I know there are a lot of folks looking to migrate. There are a lot of similarities. For example, both use east-west gateways to connect clusters. They both have end-to-end MTLS. But the big difference for me is that ambient is built on ambient, and sidecars, well, you have to use sidecars. Another difference is the APIs. For ambient, we have a label-based selector API. While for sidecars, you usually use service import and export, where you have to specify each individual service you want to be global. And again, identity verification at the east-west gateway for ambient multi-cluster ensures that only verified traffic is entering the cluster through that gateway. We've done a lot of work, and we're really proud of it, but as always, there's a lot more work to do. I think in the short term, what we want to work on are fixing lingering bugs we found through integration tests. And doing double H mode, which means double encryption, isn't free, and we want to get a better understanding of the performance implications of doing such something and compare it to sidecar and maybe other multi-cluster solutions. We're also looking to get a lot more documentation and guides for people to get started and maybe do some very interesting things like keeping traffic local if possible and only failing over to remote clusters if there's no healthy endpoint locally. And in the longer term, we're looking to give folks a better experience through tooling and guidance to migrate from sidecar to ambient, be it single cluster or multi-cluster. And obviously a lot more that I don't have time to mention. So our timeline, Istio Ambient Multicluster was released in alpha in 1.27. This was a few months ago, and last week we released Istio 1.28. Istio Ambient Multicluster is still in alpha, but this added the ability to do L7 failover and cross-cluster connectivity. In 1.29, we're hoping to have this feature be beta. And for that, we want to do a lot of the things I mentioned in the previous slides, like fixing bugs and getting better performance, an understanding of our performance. And then we're shooting for GA in 1.30, which is around May 2026. We still don't know exactly what that means, but we hope to have a stable product and API for you. So the other thing I want you folks to walk away is that we cannot progress through these feature stages unless we get feedback from the community and people trying it out. So please, please, please try it out. Tell us what works, what doesn't, what's important. Give us feedback. We need it to progress for the feature stages, and we always really appreciate any feedback or thoughts from you. Please also take the time to scan the QR code and give us any feedback. We appreciate any of your comments. And I think we have 5-ish minutes, 4 minutes for questions. So if anybody would like to step up, please do so.
We can also walk through the diagrams again. Oh yeah, there are microphones.
Yes, though they don't seem to be exactly working.
Hi, I have 2 questions. The first question is you mentioned the global scope is only exposed to service visibility. It doesn't including the security policy or other stuff. So what's the difference between the service visibility versus accessibility?
It really all comes down to what the proxies see. So we really didn't want to expand the scope of service scope beyond what we already have for other resources. We didn't want to conflate those two. So we really limited it to what the configuration we sent to the proxies. So it really just limits it from the proxy's perspective. It won't see that that services are available on another cluster. So it's really just about limiting the configuration that you're sending. So that's what we didn't want to creep any scope into other resources.
I see. So basically just, okay, I noticed I can access that service, but then I gotta go to the authentication and authorization to check if I can access those services.
It's visible from the proxy,
Okay.
and then policy is applied,
Gotcha.
based on that.
Perfect.
Yeah, and can I just add something? Yeah, this is a really important and nuanced point that we often talk about in security, which is what's the difference between being able to view a service versus being able to access it. And I think a really good example to think about this is to think about what if you have a bad actor, right? The East-West Gateway, do I have the pointer?
Yeah, you can use this guy.
The East-West Gateway, right? Oh, whoops, laser pointer here. Has a globally accessible IP. So if somebody, say, compromises a service account, they could just connect to the East-West Gateway, right? Regardless of how you do discovery, what configuration you send, right? That attacker could be in cluster A, it could be somewhere else, right? This will often be a public IP, right? And no matter how you configure service scope, or I guess it might depend, but that's a big difference of thinking, what if I have clients that are not just being poorly behaved, but are actively trying to infiltrate my clusters.
Yeah, it's there's no policy. If you just define, local scope, there's nothing necessarily. There's no policy if that's all you did. There's no policy blocking traffic. It's just that this proxy doesn't know about it, but that doesn't mean it's blocked.
Gotcha. So the second question is relative is the graph too. So you introduce a lot of failover. Does that also means when it doesn't trigger the failover, actually the traffic has its preference to routing the traffic?
So by default, other than waypoints, so other than cTunnel sending traffic to waypoints, cluster traffic is balanced uniformly. So it doesn't matter if you're in cluster B, if you're in cluster A, any pod has an equal chance of getting the traffic sent.
By default.
By default. You can configure it if you want to just use cTunnel and not do any L7 stuff. You can set traffic distribution, I think that's a field on service, or some annotations to say, I want to keep it in the close. If you have waypoints, then you can do a lot more complex things, like, as I alluded to, you can say, you can have outlier detection and have routing preferences to say, I only want to go to to other clusters, provided that they're in different regions or have some sort of topology. You want to say, I only want to fail over when things aren't good in my current region.
Thank you.
Actually, two questions. First one for like when I fail over to, let's say, from cluster A to cluster B, is it possible to set something like once you have done a failover, do not fail over again, so that you don't actually cause a storm of applications just failing over to each other?
Also, like it doesn't prefer that route even after the cluster, your local cluster is recovered or something?
Yeah, like, sometimes what happens, like my service in cluster A is down. Now I send all the traffic to cluster B. I take down the service in cluster B as well. The requests are just ping-ponging from one east-west gateway to another. Is that?
I'm not sure I 100% understand. Are you saying like there's like a stampeding herd problem?
Yeah.
I think that's ultimately going to come down to how you configure your waypoints. I'm not super familiar, but my understanding is you can configure the waypoints to start failing over traffic even before all the local clusters endpoints have been exhausted. I hope that helps.
Yeah, I think I guess we can control it from there. The other point was, let's say we have more than like for number of clusters. If the clusters is like let's say hundreds, is there a way to control how often the Cube API is called from Istio for remote clusters? For example, like each cluster Istio talking to the Cube API server of the other cluster kind of increases that.
I don't think there is now.
Yeah, let me make sure I understand. You're saying like, how do we make sure that we kind of rate limit Istio on remote API servers?
Yeah.
I don't.
Do we offer that?
Does anybody know? No, I don't think so.
No, we've done scale testing up to 30 clusters, and it's not causing problems. So if you do find problems, let us know, and we'll consider that a bug.
Okay.
Yeah, that would be great feedback or an issue.
Okay.
Thank you. Leor, did you have a question?
Yeah, you have mine where I'm full. Yeah, thanks for a great talk. I got a couple questions. Let's see what I can fit in. So first, how the traffic gets into the east-west gateway? Like the client dials a DNS name, right? The service name. How the traffic gets to the east-west gateway?
The destination IP is the east-west gateway. So what you can explain if you want.
So how it works is, if I'm understanding the question right, that because you're reading the remote API server, you know the address of the east-west gateway.
Yeah, but like what I'm saying is like the client would call foo.svc.cluster local, right? Then the control plane like configures this with the east-west gateway IP. Like
Yes. So the zTunnel or waypoint would, if it selects a remote service endpoint, then it would rewrite the destination IP to the east-west gateway IP, and the original host name that was requested by the client and the original destination port is set in an authority header.
But in this case, how would the prefer local work? Like if the control plane overrides it to the east-west gateway IP, and then how do prefer local work in this case?
Prefer local between the zTunnel and waypoint, or prefer local?
Like the client would eventually end up in the same cluster for the destination.
So by default, the prefer local, I think it only applies to the zTunnel selection of the waypoint. It would prefer the local waypoint. Otherwise, it's load balanced. Even by default, it's load balanced evenly amongst the actual destination endpoints.
Got it. So like I cannot set prefer local for the destination.
Yeah, you can.
You can, but I'm just saying the default behavior.
Yeah.
It's false by default, so you would have to explicitly set it.
On the service.
The waypoint is on by default for local.
Okay.
Yeah,
And
sorry.
then like I would get load balance
Okay.
between the
I
gateway,
think we're
east-west
getting
gateway
kicked
IP and the local destination. Okay. Do you
Yeah,
want more
but
questions? I have more.
I think we're getting kicked off the stage. So, but
All right.
we still want your questions. Please, we'll be in
All
the
right.
back, and we'll be happy to answer anything.
Thanks again.
Thanks.